So for initial value problems, I'm going to do a couple of the homework problems here. So I hope you've tried all the homework problems before you just sit down and watch me do problems. But I decided I'd go over 6. I mean, the only thing that makes 6 all that difficult is, working with, we're still kind of new at the functions like e to the x and natural log, those kind of functions. So this is only going to be one step. We're told to find y when you're given y prime. So y, of course, is going to be the antiderivative of e to the 3t plus t. And so then I want to put a dt here, okay, because this derivative is with respect to t. So I find this antiderivative. So this is where I notice on the answer key I was doing a u substitution here, but I hope we have it memorized that if it's e to some constant, the antiderivative is the reciprocal of the constant and then keep e to the same power. Okay, and remember, if we're doing derivative, right, as opposed to the derivative of e to the 3t, that would be 3, right? Not reciprocal of 3, but derivative would be 3 e to the 3t, okay? And we get the same kind of rule when we are doing things like the antiderivative or the derivative of like sine 6x, right? With the derivative, it would be 6 cosine 6x, and then the antiderivative would be 1/6. Now the antiderivative of sine is negative cosine, so it would be 1/6, right, for the antiderivative of sine. Okay, so same concept here with the e and the trig. So I'm hoping you just memorize those. So that will make your life much easier. Now the antiderivative of t is t squared over 2 and plus c. Okay, so then we're given the information that we need to solve for c. So we are told here that when t is 0, y is 1. Okay, so then we plug in. And I know in class I talked about how we love it when we plug in 0 because usually that makes all the terms 0, but that is not true for e or for trig. Okay, it'll be true right here because t is 0. Okay, 0 over 2, right? So that's just 0 plus c. And 3 times 0 we know is 0. Okay, so what is e to the 0? I mean, what is anything to the 0 power? Okay, and I hope we all know that anything to the 0 power is 1. So we have 1/3 times 1 plus 0, so I'm not going to write that, plus c. Okay, so what is c, right? 1/3 times 1 is just 1/3. Subtract 1/3 from both sides, right? I hope we're good enough at this math that we don't have to grab our calculators or anything like that. If I have a whole and I take away 1/3, I'm left with 2/3. Okay, so that's my value of c. So then my final answer, I have to go back up here and just put in, and actually, instead of rewriting the whole thing, because I'm going to be, it's so cumbersome for me to write here, so I'm going to be kind of lazy and just put in the 2/3 for c, and then that is my final answer. This was only a one step because I was given a derivative, had to find the original. Now I'm also going to do 7 with you. So 7 is a 2-step, right? Because it gives you the second derivative and asks you to go all the way back and find y, right? So it's giving you the second derivative of y with respect to x. So if I want to find the first derivative of y with respect to x, okay, this was the second derivative, so the first derivative is the antiderivative, and this is not hard math at all, right? This is simple power rule. Okay, so the antiderivative here, and this is with respect to x, so I just have to increase the power by 1, divide by the new power. So increase that to x cubed, but when I divide by 3, 24 divided by 3 is going to give me 3. Okay, so I increase that to x cubed, but dividing by 3, 24 divided by 3 is 3. And I get minus 10x plus c. And so I'm told right here that, so this is dy dx. And I'm told right here that when x is 1, dy dx is 3. Okay, so I use that information. This is dy dx. So I come down here and say, okay, when dy dx is 3, that happens when x is 1. And luckily on this handout, they don't give you a whole lot of hard arithmetic. I won't give you hard arithmetic when I put a question like this on a test or on the final. So let's see, this is just 3 minus 10, which is -7. Right, -7 plus c equals 3, so c equals 10. So again, I'm going to not rewrite this. I'm just going to come back up here and replace c with 10. And I have the answer key in front of me, so let me just double check this. Okay, I'm sorry, hang on. Number 7. Wait, my apologies. What did I do wrong? You know what? I think there's actually a mistake on my answer key. No, I'm sorry. I made a mistake right here. Well, that is silly, right? 24 divided by 3 is 8. I don't know why I put a 3 there. So that's an 8. Okay, well then that changes everything. So this is why it's smart of me to sit here with my answer key in front of me. So this will be -2, and then I add 2 to both sides. There we go, and c is 5. Okay, so now I'm ready to find y. So y is the antiderivative of this, of the 8x cubed minus 10x plus 5. Okay, so again, this is very simple power rule. Increase the power by 1, divide by the new power. All right, let's see if I cannot make an arithmetic mistake this time. This becomes x to the 4th. 8 divided by 4 is 2. Okay, so 2x to the 4th. Increase the power by 1, but divide by the new power. So the new power is 2. Divide 10 by 2, I get 5. And then this is 5x plus c. And again, I am told here that y is going to be 5. So this time I'm using this information, that when x is 1, y is 5. Okay, so I'm using what I circled there in blue. So I plug in 5 for y, 1 for x, and so it's very convenient that 1 to any power is just 1. Okay, so I'm not even going to write that. 1 to the 4th is 1, 1 squared is 1, anything times 1 is itself. All right, so 5 times 1, this will cancel out, right, because I have -5 plus 5. So it looks like when I solve by subtracting 2, I'm going to get c equals 3, making my final answer here. So again, I'm being lazy, not rewriting the whole thing. My final answer is right here. So I had mentioned checking your work by finding the derivative, but even if I had found the derivative back here when I made a mistake with my antiderivative, I never would have, actually no, it was early in here. I probably would have found that mistake. We can't necessarily find out if we made a mistake getting the right constants, But at least if we take the derivative of this and then find the second derivative and see that I get back to where I started, that helps us to see that at least we did the correct work involving the variable part of the expression. So again, I hope this helped with initial value problems. I hope you're not finding them too difficult. Again, some great review for the final. For example, number 4, right? We haven't looked at problems like that in a long time where we bring the denominator upstairs, right? And so here, that would be 3x to the -4th, right? And then we increase the power by 1, divide by the new power. So like I said, great review and practice for the final.